Now let us proceed to the discussion. So for the reviewing concepts, ordinary, deferred, perpetuity, annuity due. So lesson 1, types of annuities. But first, let's proceed to the definition of annuity. Annuity is a series of equal payments made at regular intervals for a period of time. So first type is ordinary annuity. It is the equal payments are made at the end of each period. So for the present value formula, P is equal to A multiplied to the quantity of 1 minus open parenthesis 1 plus R over M close parenthesis raised to negative M multiplied to T all over R over M. Next, for the future value formula, F is equal to A multiplied to the quantity of 1 plus R over M close parenthesis M multiplied to T minus 1 all over R over M. Now, with that given formula, it is where P is equal to the present value, F is equal to the future value, A is equal to the regular payment made, R is equal to the interest, M is equal to the number of compounding periods per year, and T is equal to time duration in years. Proceeding, let's have a sample problem. It is stated that John owes his friend 5,000 pesos with interest rate of 2% payable quarterly. What equal payments at the end of each 3 months for 4 years will discharge his debt? Now let's use the formula for the present value, which is P is equal to A multiplied to the quantity of 1 minus open parenthesis 1 plus R over M close parenthesis raised to negative M multiplied to T all over R over M. Now for the given, P is equal to 5,000 pesos, R is equal to 2%, which is 0.02 in decimal form, M is equal to 4 because it is quarterly, T is equal to 4 years, and for the unknown is A, which is the regular payment. So, substituting the given to the formula, we will yield 5,000 is equal to A multiplied to the quantity of 1 minus open parenthesis 1 plus 0.02 over 4 close parenthesis raised to negative 4 multiplied to 4 all over 0.2 over 4. Now with this, we must multiply both sides by 0.02 all over 4 to cancel out the denominator. And it is shown in the next line. Then evaluating the second line, we will have 5,000 multiplied to 0.02 over 4 all over 1 minus open parenthesis 1 plus 0.02 over 4 close parenthesis raised to negative 16. Then evaluating this, we will have a value of A is equal to 325.95 pesos per 3 months. Next type is the deferred annuity. It is defined as the payment begins only after the given time interval has passed. So for the present value formula, P is equal to A multiplied to the quantity of 1 minus open parenthesis 1 plus R over M multiplied close parenthesis raised to negative M multiplied to T all over R over M multiplied to the quantity of 1 plus R over M close parenthesis raised to negative K, wherein K is equal to the period of deferral. And for the variables, it is also the same with the previous formula. Now proceeding to the sample problem, John wants to receive an income of 8,000 pesos every year for the next 12 years. If the purchase of deferred annuity will start 3 years from now, how much should he deposit if the interest rate is 6% compounded annually? So with this, we will use the formula previously stated. Then the given is A is equal to 8,000 pesos, T is equal to 12 years, R is equal to 0.06, M is equal to 1 because it is annually, and K is equal to 2. For the unknown is P is equal to the P or the present value. And for the solution, we will substitute the given A, T, R, M, and K to the formula above. So we will yield this one. So evaluating, we will come to a simplification of 4,024.245,091 all over 0.06 multiplied to the quantity of 2,500 all over 2,809. Then simplifying this, we will get the value of P is equal to 59,692.73 pesos. I hope it is all clear for you. So next, for the third type of annuity, which is the annuity due. It is defined as the equal payments are made at the beginning of each period. So for the present value formula, P is equal to A multiplied to the quantity of 1 minus open parenthesis 1 plus R over M close parenthesis raised to negative M multiplied to T all over R over M multiplied to the quantity of 1 plus R over M. So for the future value formula, F is equal to A multiplied to the quantity of open parenthesis 1 plus R over M close parenthesis raised to M multiplied to T minus 1 all over R over M multiplied to the quantity of 1 plus R over M. So next, jump 3,000 4 times a year in an annuity due 6 years at an interest rate of 8% compounded quarterly using the ordinary annuity table. Solve for the total value of the annuity due at the end of 6-year period. So proceeding, the given is A is equal to 3,000 pesos, M is equal to 4, which is quarterly, T is equal to 6 years, R is equal to 8%, in which the decimal form is 0.08, unknown is the total value. So to get this, we must first get the value of n. So the number of periods is equal to m multiplied to t, in which m is equal to 4 and t is equal to 6. And 4 multiplied to 6 is 24. Therefore, n is equal to 24. Then next is total investment period. We will just add one to the number of periods. Periods in this instance is 24 plus 1, which will yield 25. So for the interest rate, which is I, is equal to R over M. Then we will substitute the given of R and M to the formula. We will yield 0.02 or 2%. Then we will find this in the table. It is indicated and encircled that the value is 32.0302. Then we will use this value to multiply it to A, which is 3,000 pesos, and we will yield 96,090.60. This value will be subtracted by 3,000 for the A, and in which the answer will be 93,090.60 pesos. So the fourth type of annuity is perpetuity. From the word itself, it is the periodic payments which continues indefinitely. So for the present value formula, P is equal to A over I, in which I is equal to R over M. So we will derive. Then what is then for the sample problem, it is stated that what is the present value of a perpetuity of 3,000 payable semi-annually if the money is worth 6% compounded semi-annually? So for the solution, we'll first get P, in which 3,000 is A is equal to 3,000, then R is equal to 6%, or the decimal form in which it is 0.06, and it is compounded semi-annually. So it is semi. So from the word itself, to M is equal to 2. Then we will yield a value of P is equal to 1,000